Hello, my name is Masha Goodspeed. This is my presentation on what I call a smart cane. The reason that I chose this project was because we were tasked with having a worldly issue project, and so there are 250 million visually impaired people in the world, and that equates to 1 in 25 people, and 50 million of them use a cane, and so there's a lot of white cane users in the world. And one of the main issues of the white cane is that it only detects what it's tapping on, which is the ground, so anything above that it does not detect. So anything like low-hanging branches, poles that are in the way, the person with the cane will just run straight into. And so I wanted to make a project that had a few key features. I wanted to use ultrasonic sensors to detect the obstacles from 10 feet away because I thought that was a good distance. It was like enough warning that they could do something about it, but it wasn't so much warning that they were too far away to worry about it. It vibrates since it can't have any visual cues. And then it has different patterns and intensities to let the user know how far away it is so they know how quickly to react. This is my little system diagram. So as you can see, there's a little pothole down there, and then also a little skateboard rail. And so both of those, a cane, well, so the pothole a cane would recognize, but not until it was in the pothole, and then the user might be too close. So in this scenario, you'd hope to inform the user that there was a pothole before they got to it, and then it would not detect the rail because it's above ground level, and so the cane would just go under it until the cane hit it like up in this level, and then again the user was basically tripping over it at that point. And then it has a buzzer that causes vibration that the user can feel, as you can see by these little waves. And then there's 3 sensors that are ultrasonic that send out waves to detect the obstacle, and it's all controlled by a microcontroller. And then that's my little flow chart. So it just shows how it progresses from the user to the obstacle and the feedback. And then this is just my detailed system diagram. So I have 2 of the same ultrasonic sensor, and then I used one that the transmitter and the receiver are combined into one, so that when I screwed it to the bottom of the cane, it wouldn't be as large. And then I have 2 of my little buzzers, and then it's all controlled by an Arduino Nano. And there's a little housing right up below, because this black part is where they would hold on to the cane. And so having it right below that, it's not in the way, and still high enough that it can detect objects around the chest level. This is my circuit layout. So as you can see, there's just the 3 ultrasonics. It's controlled by a 3.3 volt battery, and then there's a step-up circuit that brings it up to the 5 volts that all these sensors want to see. And then I also have my vibration motors that have a motor circuit to prevent them from frying the Arduino. And then this is just a budget. I spent $85. I mean, technically a little less than that because the school already had a few of these items. And like a step-up boost converter, like someone else bought for their project, they bought 6 of them, so I just stole one of them. And then the ultrasonic sensors, the blue HC SR1, St. Denis uses for his labs, so I stole those. The reason that I chose this ultrasonic for 2 of them was because of their size, and they were already available, and they work very well for what I need them to do. And these are located in the middle of the cane, and they're in front of the user to detect 4 meters, 2 meters, and then at an upward angle for 1.6 meters. And then this is why I chose an ultrasonic sensor over the different type of sensors that I could have used, because I wanted to use an Arduino, and then they're pretty small, and like especially when you get them to combine the transmitter and the receiver, they're very small. And then they also are independent of light, smoke, dust, and material, which is what I want, because if the user is using this at night, I don't want the sensors to not work if it's dusty out or hazy out, I want the sensor to work, because people walk around outside or in a building all hours and weather. And then they can run on 5 volts, and they only draw 15 milliamps, which is very important when running it off an Arduino. And then this is how an ultrasonic works. It just sends signals from a transmitter, and then the receiver detects when it comes back, and then determines the distance based on this equation. Some of them can detect humidity because that'll affect how sound travels, but those basic ones don't. They just use 331 meters per second to detect it, and then if there's no object, it never gets received, so it's not picked up. And then this is the vibration motor I chose. It's super tiny. It's also very inexpensive. It was only like $2, and it can run anywhere from 2.7 to 3.3 volts DC, which is very convenient for running it off an Arduino. And it's very, like, you can really feel it, like it's a strong vibration motor. Also, it's because it has to go through the little case that's on the cane, so if it wasn't too strong, you wouldn't really be able to feel it. And it also needs to be pretty strong because there's one on the left and one on the right, and so you have to be able to differentiate between those two. So if it was just like a light vibration, it would just like vibrate the whole box rather than a certain side. And then this is my motor circuit, which I had to make to protect the Arduino. It's pretty basic. You basically use it for any motor. I'm just feeding in 5 volts, then 3.3 volts. I have a resistor, a transistor, and a flyback diode to prevent the motor from feeding back current. And then this is the microcontroller I used. We got them in the last class, so they didn't cost me anything. I tried using a different one that you program, but that draws less current, but we got the really cheap ones from China that didn't work with the computers we have here, so I just ended up using this because I didn't have enough time to get one of the other ones. And this one's still pretty small, so to put it on a cane was not too obtrusive. And then this is my boost converter because I wanted to use a very long-lasting battery that runs at 3.7 volts, and all of the things that I want to run at are 5 volts, and so this will take a 3 volt to 30 volt input and output 5 volts to 35 volts, but if I put 3 volts in, it'll output 5 volts. And it also operates at a good temperature and is pretty small. This is my ultrasonic, and this is just showing the different waveforms, and that this is the trigger waveform, so it's sending out the pulse, and then this is telling it the time that it took to get back, and so the closer the object, the smaller it is. And this is important to me because my code then takes this, and if it detects that it was pretty close, it will vibrate pretty quickly and at a fast rate, and then if it receives this one, it'll go at a slower rate. And then this is what I basically just said, but it just determines the distance and then writes a certain percentage of the duty cycle that my vibration motor requires to allow the user to differentiate from an immediate obstacle to a further away obstacle. And that was my presentation. Any questions?
So you haven't written code yet?
Yeah, well, it's like breadboarded, yeah.
I'm just wondering what, you mentioned the fact that the echo time determines the vibration, something.
Yeah,
What changes? Intensity of vibration, frequency of vibration?
yeah, all of the above.
Okay. Okay.
Because if the object is closer, I want it to be more intense, so the user is more aware of an immediate action is required.
Okay. And is there something about the vibration that changes for high objects versus low objects, or is it all?
I didn't write
At this
that,
point?
no,
Okay.
but I suppose I could.
What, on the cost stuff,
Yeah,
I know you said lots of stuff was essentially free. So do you know what it would actually cost to make one of these, if you had to buy everything?
well, that's what I said.
Is that the number, $85?
Yeah.
Oh, okay, I thought you were saying it was free, but you included all the costs.
Yeah.
Okay. And one last question, so, have you tested this to see what size objects it'll detect? Like if you're coming along and, would it detect this this cable? At what distance would it detect it? Or if you mentioned low-hanging branches, will it detect the twigs if you're going into those, or does it have to be a fairly large branch on the tree?
Yeah, I mean, it can't be super small. Like, I didn't test it with that wire, like, I don't know how close we have to get. But, I mean, if someone ran to that wire, probably wouldn't be the worst thing either. It detects something that's like the width of my arm, I'd say.
Okay. So at some point, you may want to, do a measurement
Yeah.
and just see. And I think it'll vary with the distance. I mean, the closer you
Yeah.
are to this wire, the more likely it'll reflect and you'll get something,
Yeah.
so. But I suspect from 1.6 meters away, it wouldn't detect twigs on the end of the branch, but it might detect, something the size of my thumb. So. Any other questions?
Yeah, so have you ever considered, like, in the future possibly patenting this and then selling the patent to a company that manufactures these canes?
No, I just needed a project, my senior project. Actually, there are a bunch of people that have patented these, there's different variations of them. Like, there's one variation I saw that's kind of like, the one when you fall over, whatever, life alert. It's like that, but you like install it on a cane. And so,
Can you go to circuit layout real quick? I wrote down that you said something about the step-up converter. Is that on there?
well, no, because it's just an external
Oh, okay.
little thing that I bought, so like, I would just wire it to that.
Say that again, what was the last thing?
Like, I would just wire it to this, because
Okay.
it's an external.
But
little
that's-
doohickey.
Yeah, so it takes the 3.3 and raises it
It's
to
the
5.
boost converter that I have.
Yeah. So where does the 5 volt come into this board?
Do the Arduino Nano?
Okay. I think you need one more screw terminal or something to bring that 5 volt signal back in. You're not going to solder it to the Arduino.
Well, no, I was gonna have it go through the cord.
Oh, okay. Okay. So you'll need a modified USB cord or something.
Yeah.
Okay. Okay. All right, any other questions? All right, thank you.